Okay, so before we start, as you can see in this week's timetable, we have a physics doubts and discussion session on Sunday also. So we will be discussing whatever questions or doubts you have on Sundays in Sunday's session, including if you have any doubts from the assignments that I've given so far, because I have given you hints and in certain cases solutions in quite a bit of detail also. Okay, I will be discussing a couple of questions from the previous assignment to begin with. Okay, but still, if you need more detailed explanations in some of the questions, then you can also discuss that during the session on Sunday for doubts and mentorship. Anyhow, so let's begin. Okay, so I'm just going to discuss some examples of questions from the second assignment that I had given. Okay. So for example, so this will just serve as a quick recap of the concepts we have discussed in the last lecture also. Okay. So for example, question number 1, part C, y is equal to cube root of x. And I want to calculate dy by dx. So here I will just simply use the formula for differentiation of x to the power n, which we saw in the previous lecture, is given by this. So just apply that formula over here. So okay, this cube root of x implies that x's power is 1 by 3. So instantaneous rate of change of y with respect to x comes this, becomes, which I can write as this, or I can write this as this, or I can write this as, sorry, okay. So many different ways of writing the answer. So even this step would be correct. This step would be correct. This step would be correct. It's just a way of writing it. Okay. That is this part. Then similarly, if we look at the part F over here, y is equal to x square minus 2x plus 6. So in this, I'll be using two properties of differentiation. Okay. So one of the properties is that differentiation of some constant multiplied by a function becomes the constant times differentiation of the function. So I'll be making use of this property. And the second property is like a distributive property, that differentiation of the sum of two functions is equal to the sum of their differentiations. And for that matter, this could have been the difference of the two functions also. Then it becomes the difference of their differentiations. Okay. So I'll be using these two properties to find out the differentiation of this. You need just make a note down of that section.
So can you elaborate the second property?
Yeah, when I explain to you in the application in this question, you will get it. Okay. See, if you're differentiating the sum of two terms, f1x is an individual function, f2x is an individual function. So y is the sum of these two functions. Then we can solve it like a distributive property, that when you take the operator inside this bracket, it just becomes the operation on the first function plus the operation on the second function, or the operator on the first function minus the operation on the second function. Is it clear now, Beta?
Sir,
Yes,
in
sir,
the
got
F
it.
question in the assignment, it was x cube minus 2x plus 6.
Oh, sorry, it's x cube, is it? My
Yes,
mistake.
sir.
Okay. Yeah, that's correct. I'll just make a correction. Okay, so this second property is clear now.
Yes, sir.
Okay, so let's just apply that over here. So in the first step, we can just replace y with this whole term. Okay. Then we can take the operator inside. So it becomes differentiation of the term x cube minus differentiation of the term 2x plus differentiation of the term 3. So you can see that differentiation of x cube will become 3x square. Differentiation of this, we can take the
So it is
2 out.
plus 6.
Hmm?
In the question, it is plus 6. You have written plus 3.
Oh, sorry. Okay. Okay. Then you can take this outside, and this is differentiation of a constant. Okay. So remember the property that differentiation of a constant is 0. So this becomes 3x square minus 2, and that becomes the answer. Okay. Or we can also use the property that differentiation of a linear function is just the slope. Okay, so we can use this also. So then we could have written this entire term's differentiation directly as minus 2. Okay, so hope this is clear. Okay. Now let's come to question number 2. So in question 2, what is happening is there are two objects which are starting from the same position. I mean, same x coordinate parallelly. So let's say this is x equal to 0 at time t equal to 0. But they have displacements which are given in this manner. The displacement of A as a function of time is 8t square, and displacement of B as a function of time is 4t cube. Okay. Distance or displacement, whatever, it's along a straight line. So that's one and the same thing. Okay. So now, for example, if we have to talk about, so if you understand this, what's happening is that, for example, at t equal to 1 second, A has covered a distance of 8 meters, B has covered a distance of only 4 meters. So you can see that A is ahead of B. But for example, if you check at t equal to 2 seconds, let's see what's happening. A is at a displacement of 32 meters and B is at a displacement of also 32 meters. So by now B has caught up with A, so they are alongside. But now if you check at a time like 3 seconds, A's displacement is 72 meters, okay, and B's displacement is how much? 27 into 4, right? So that is 104 meters, sorry, 108 meters. Okay. So now you can see that B is ahead. So getting an idea that it's an interesting kind of situation that initially A is ahead, but eventually B overtakes A. Okay, so that is the basis of the whole question. So for example, this is also giving us the idea that the instantaneous velocity of A will be the instantaneous rate of change of distance or displacement. The instantaneous velocity of B will be the instantaneous rate of change of B's displacement. So you can see that A's velocity as a function of time will become how much? 16t, whereas B's velocity as a function of time will become 12t square. So you have additionally this information also from this. So now, for example, if you ask that when does B overtake A? Okay, so that is at the instant when displacement of B just becomes equal to displacement of A. So that after that, the displacement of B, so suppose this is at some time t naught. So then t greater than t naught mein kya ho jayega? Displacement of B will become greater than displacement of A. So it's overtaking at this instant. And that instant you can see is 2 seconds that we already checked. That displacement of B, which was 4t cube, should become equal to displacement of A, which was 8t square. So that after this moment, this should be greater. So you can see here. So at 2 seconds, their displacement is same. And after 2 seconds, B's displacement is more. Whereas you can also see that at any time less than 2 seconds, A's displacement is greater than B's displacement. So that is telling us that B overtakes precisely at t equal to 2 seconds. Okay, so if you were to visualize this, this is what is happening. They start alongside at t equal to 0. But for example, if you look at t equal to 1 second, A is ahead, B is behind. But then if you look at the instant t equal to 2 seconds, A and B have come alongside. And you will also realize that at t 2 seconds, B's velocity is greater than A's velocity. That's why the overtake is happening. Okay. So at any time greater than this now, for example, at t equal to 3 seconds, by now B has moved ahead and will continue to move ahead. we put together the information that we have seen earlier. For example, in this, if you also supply the values of velocities, see that at t equal to 1 second, E's velocity is 16 meters per second. B's velocity is 12 meters per second. So B is also traveling slower than E. But by the time you come to this, you can see that B will become faster. So this is, at this stage, it is 32 meters per second for this one. And this one is 48 meters per second. So B is already faster. And that trend continues by the time you come 3 seconds. That is what you can see in this diagram. So for example, you are also asked that when does B's speed become more than A's? So that is when VB is greater than VA. So VB we had seen was 12t square. So that should be greater than VA, which was 16t. So we can see that that happens for so this is the precisely the moment at which B speed becomes more than A speed. Okay, so this one is like this. Okay. Then question number 3, I think should be okay. I have discussed in quite a bit of detail. Let's come to question 4. Question 4, we have to just do a bit of irritating algebra, that's all. So let's come to, for example, question 4, part D. So y is given to us as this rather lengthy kind of expression, x square multiplied by root x minus x cube, the whole thing divided by 2x. Then I want to find dy by dx. So what I'll do is I'll first simplify this a little bit. I'll write this as x square root x divided by 2x minus x cube by 2x. So further, this will become 1 by 2 into x to the power 2 plus half minus 1, okay, minus 1 by 2 into x to the power 3 minus 1. So after having done all this simplification, this can be written as 1 by 2 x to the power 3 by 2 minus 1 by 2 x square. So once I've written it this way, it's become simpler to differentiate. So next you can see that you can simply apply the differentiation operator. So in simplified form, this is this, okay. So this becomes 1 by 2 differentiation of x to the power 3 by 2 minus, again take the 1 by 2 outside, into differentiation of x square. Right. So that becomes simple enough. Yeah, quotient rule I will explain, Prathamesh, but that we have to learn that rule first. Okay, so that we'll be doing today. So in this assignment, you were not meant to solve any of the questions by product or quotient rule, because I hadn't taught that yet. Okay.
Sir,
Yes.
sir, we can also solve all of these questions by using f of delta x plus x minus f of x upon delta x.
Yeah, but that will be so lengthy, na? You will have to solve the limit for each one, na? Then what is the whole purpose
Yes.
of learning the formula of differentiation? No? The idea is that, see, we have used that limit method to already define the differentiation of any general x to the power n is equal to nx to the power n minus 1. This has come from the definition only. No? This has come from the fact that differentiation of x to the power n is that limit delta x tending to 0. That thing. The
Yes, sir.
algebra. So the idea is, once we have done this derivation, we don't want to repeat it every time for every question, because you can see the number of steps will become very large otherwise. So both this formula as well as the properties that we are using over here, like this property over here and all that, they're all coming from the definition itself. So once we are clear with the formula derivation which has come from the definition, we don't need to apply it every time in a question. Okay. Understood, na, Jina?
Yes, sir. Thank you, sir.
Okay. Okay. And like in physics now, our focus is going to be on application of the formula directly, so that we can efficiently find the derivative or the rate of change with minimum number of steps. So definitely we will avoid the derivational method and we'll go for directly the formula based method. Okay, let's see E part also, because I think a couple of you had some confusion in the E part. So in this, y is square root of x into x square plus 5x plus 2. So what we will do is first simplify this by taking square root inside the bracket. Okay. So y is equal to root x into x square, okay, plus root x into root x. Oh, sorry, this is 5x, not root x. So into 5x plus root x into 2, or y is equal to x to the power 5 by 2, correct? Plus 5x to the power 3 by 2 plus 2 times x to the power half. And now we are in the position to differentiate it by using a standard set of properties. So that is differentiation of x to the power 5 by 2 plus 5x to the power 3 by 2 plus 2x to the power half. Finally, you apply the x to the power n formula again. So 5 by 2 x to the power 3 by 2 plus 5 into 3 by 2 x to the power half plus 2 into half x to the power minus half. And write it like this. Okay, people, so hope this is also clear.
Sir, can you solve the C part as well?
Which part, beta? B?
C, sir.
C, okay, I'll do that also. C part is interesting. So actually C partner, it's technically not a function because it's given in y square form. So one way is that, okay, we could contradict the question only that it is not a function. Okay. X to the power 6 minus.
Also, we can convert it in x minus 3 whole square. So the square will
we
be
can convert it also. Okay. So that is also equal to x cube minus 3 whole square. That's all right. Okay. But this actually implies that y could be plus or minus of x cube minus 2. Sorry. Actually, this is even more complicated because this is mod of this. Okay. Because if I say that a square is equal to b square, okay, then it means a minus b into a plus b is equal to 0. So a is equal to plus minus b. Okay. So this is technically not a function. Okay. Sorry, we don't really need the mod here. Let's say it is. Okay. So if it's not a function, then there's no question of rate of change. Or what we can do is, so we can contradict the question. So rate rate of change becomes questionable what it is. Okay. Or what we can do is we can break it into two functions. Okay. So this expression could possibly mean that if it means that y is equal to x cube minus 3 . So that is one possible solution of this. Or if it could mean that y is equal to minus of that, so 3 minus x cube. So in this case, dy by dx would be 3x square, as you can see. Or in this case, the instantaneous rate of change would be minus 3x. So we can leave this answer this way also, that it's an ambiguous question because we actually don't know what y is as a function of x. There are two possibilities, and according to the two possibilities, there are two possible answers. Okay, people, so hope this is clear. Okay, now the last question, the fifth one, was the one which was a little bit tricky out of all the questions. Not a direct question, slightly indirect. Okay. So the fifth one, what I told you is that it's given that y is a polynomial function, okay, of x. So it comes in the general category of polynomial functions. Such that, so we can say that, for example, y as a polynomial function of x in general will be this sort of a power series. Okay, going up to what power initially we don't know. Okay, so let's say it's going up to some power x to the power n. Okay, but now see, the next information given is going to make things a little bit easier for us because it is given that the instantaneous rate of change of y with respect to x, that is a quadratic function. Okay, where a, b, and c are some constants. Okay. So now if you connect this with this, you'll realize that y is a cubic function. Is this point clear why it is a cubic function? This was the main thing. Huh? You have to make a guess that it's a cubic function, because if you differentiate this in general, go on differentiating the terms, you'll get 0 plus a1 plus 2a2x. Okay. Plus, if we add some third term here, a3x to the power 3. So this one's derivative will become 3a3 x square. The next term's derivative will become 4a4 x to the power 3, like this, going up to n x to the power n minus 1. So you can see that if the polynomial has a degree n, then the rate of change will have a degree of n minus 1. Okay. So how we know this? We know that because dy by dx is a polynomial of degree 2, because it's quadratic. So that implies that y is a polynomial of degree 3, or a cubic function. This is a quadratic function. So once you realize this fact, then you can use all the other information. Okay. So now, in fact, the way I have solved it, I have just taken y as like this. Suppose where p, q, r, s are constants. So and this is given to us as ax square plus bx plus c. So by comparison, we can see that a is equal to 3p, b is equal to 2q, and c is equal to r. Okay. Now what else is given? It is given that y is equal to 0 at x equal to 0. So substitute that in this first equation. And this is the second equation. So substitute in first equation.
Sir, how we got a is equal to 3p, b is equal to 2q, and c
Compare
is
these
equal
two
to...
equations. The coefficient of x square has to be same on both sides, left hand side and right hand side.
So
Yes.
shouldn't it also divide by 3 because to get ax square?
Sorry. Divide by 3, why beta? See, we are equating two quadratic equations. No? If I say that 3x square plus 2x is equal to, let's say, alpha x square plus beta x plus gamma, for example, what it means, this equation? It means that the coefficient of x square is the same on both the sides. So alpha must be 3. The coefficient of x must be same on both sides. So beta must be 2. Okay. And the coefficient of the constant term must be same on both sides. So gamma must be 0.
Yes, sir. Okay.
Understanding? So like that over here, we're just comparing. Here PQRS are also constants and ABC are also constants. So they must be constants that are related in this way. Is this clear now?
Yes, sir.
Okay. Okay, so having done that, now we can understand that, okay, so S, okay, now also given to us directly in the question is 4 other conditions. The first condition is that y is 0 when x is 0. So substitute that in equation 1. So that is telling us that substitute x as 0. So we'll get y is S. So that S must be 0. So that's one thing we are getting. Okay. Then it is also given that y is equal to 6 for x equal to 1. So again, substitute this in the equation 1. So I should get left hand side as 6. When in the right hand side, I take the value of x as 1. So p plus q plus r should be equal to 6. Okay, so there's another equation that I'm getting. S is already 0, so I'm not taking S into the picture. Okay. Then it's also given that y is equal to 0 for x equal to minus 1. So again, substitute that in the first equation. So I'm getting Acha, when I convert this to, so I'm getting 0 should be equal to minus P plus Q minus R. Okay, so now see, these two equations are very interesting. P plus Q plus R is equal to 6, whereas minus P plus Q minus R is equal to 0. So if you just add these two equations, we'll get the value of Q. 2Q is equal to 6. So that means Q is equal to 3. There's one more term I'm getting. I've already got S. Now I'm getting Q also. And from Q, I'm getting the value of B also. Okay, so that means B is equal to how much? 6. Okay. And then I have also one more thing which is given to me, that dy by dx, the rate of change, is equal to 2 for x equal to 0. So this I should substitute in which equation? The second equation, because dy by dx is given in the second equation. So substitute this in the second equation. So 2 should be equal to r, because substitute the value of x as 0. So you get this. Okay, so I'm getting this. So once I've got this, now I can make use of either of these two equations to find the value of P. So first of all, R is equal to 2. That means the value of C is also equal to 2. Okay, and that means that, for example, P plus Q plus R is equal to 6. So that means P plus 3 plus 2 is equal to 6, which means that P is equal to 1, which also means that A is equal to 3, because A is equal to 3. So now I know the values of A, B, and C. Okay. And I also know the value of Y as a function of X, because P is 1, so that's X cube, plus Q is 3, okay, plus R is 2, and S was 0. So I can see that its derivative is 3x square plus 6x plus 2, which also shows me the values of A, B, and C. So this is like a investigative type of question, that some conditions are given to us. We have to investigate those conditions in the equations that we have, and from that we have to back calculate and find the unknown quantities like A, B, C or P, Q, R, and then there's a relationship between A, B, C and P, Q, R accordingly. Okay. Okay, so this is a discussion of few of the questions from the worksheet, but I think you should be able to complete the worksheet without too much difficulty now. And I've also given you the answer key and some basic hints. So any other questions? Okay. But as I have already mentioned once before, that this week onwards, you're also having doubts and mentorship sessions in physics. Okay. So you can always discuss any pending questions which you have not been able to complete. You can discuss.
You also explain the third question?
Can, but the thing is, like, we are running out of time a little bit. Okay. Okay, let me see. Because if I discuss each and every question after having given you the hints also. So third question, beta, is quite straightforward. If you just follow the hints and solutions that I have given. So firstly, y is given as a quadratic function of x, and you have to just find the values of y for different values of x. So for the first partner, you just substitute the value of x, for example, as -1. So you'll get the value of y as -9. You substitute x as 0, you'll get y as 0, and like that. So there are 12 points that I've given you, or whatever. So for each of them, patiently you have to substitute the value of x in the quadratic equation and find the value of y correspondingly. Okay, so you will get ordered pairs. Okay, and then you have to plot these ordered pairs on a two-dimensional graph and draw the rough graph of the function itself. Okay, so this part is clear?
Yes.
Sir, is it possible to get two values of same value of y by two values of x?
Yes, that's always possible, no? Because see, we have seen that particularly quadratic functions or polynomial functions, they have this kind of property, no? Like, for example, this particular quadratic function, when we draw it now, you will see it will come out to be like this. Okay, so it is having multiple values of x, which have the same value of y. It is happening that way. Okay, so for example, you will see here that the value of y for x equal to, for example, 3. Okay, it's 24 minus 9. Okay, yeah, so that is 15. Okay, now that value repeats at 7. Okay, sorry, that value repeats at not 7, it repeats at 5. Yeah. Okay, so that too we have seen, last time also we saw the graph of quadratic function. That always happens. Okay, what should not happen for a function and will never happen for a given function's graph, this kind of thing cannot happen. This kind of thing cannot happen, that for the same value of x you are having multiple values of y. This cannot happen, but this is always possible. You can have multiple values of x at which the values of y are common also. You can have a graph like this. Okay, so here there is more than 2. In fact, there are n number of values for which the value of y is repeated. Okay, yeah, now coming to the next part, what we have to do is you have to find the slope of the tangent at each of these points. So how we find the slope of the tangent? If the function is given to us, this is question number 3. The function is given to us as 8x minus x square. The derivative of the function, you differentiate this. Okay, so you get 8 minus 2x. So slope of the tangent at any point is the value of the derivative. So for example, if I want to find slope of the tangent at x equal to 3, so that is nothing but the value of dy by dx at x equal to 3. So that is 8 minus 2 into 3. So that is plus 2. So this is the slope of the tangent at the point x equal to 3. So going back to the graph, at the point x equal to 3, if I draw a tangent line at this particular point, so that tangent line will have a slope which is equal to 2, or it will have a tan theta which is equal to 2. Okay. So like that, for each of the given points, you find out the slope of the tangent.
Understood, sir.
Understood now? Okay. Okay, so with this, let's move ahead to the next few things about differentiation. Okay. So we've already seen that if y is a function of x, then the instantaneous rate of change of the function can be calculated by doing the operation of differentiation. Okay. Now, sometimes what we do is we learn few things about notation over here today. Okay. So this is instantaneous rate of change of y with respect to x, and this here is called the differentiation of the function fx, okay, with respect to x. So this is the operation of differential calculus. Okay. So we have seen all this, that for example, if y is equal to x cube, then differentiation of this will result in 3x square. Okay, by this operation, we have seen all this. Okay. Now, additionally, one thing we'll see is one shorthand notation that we use in calculus, that the differentiation of a function is written in shorthand as the prime of the function. Okay, so this shorthand notation becomes important when we are dealing particularly with lengthy functions. And this f prime x is called the derivative of fx, which is nothing but the rate of change. So you can make a quick note of this point over here, that what is the meaning of derivative of a function? It is rate of change of the function. So for example, if I have y is equal to square root of x, and I say find the derivative of this function. So the derivative of this function will be differentiation of this function, which you know is this. So this one is the derivative. Okay, so there's nothing new here. It's just that it's a particular terminology that we call the rate of change of a function as its derivative. So there's a shorthand notation that we use in calculus, that the differentiation of a function fx in short form can also be written as f prime x. Okay, or we can use any other symbol for a function also, that differentiation of, let's say, another function gx is g prime x. Okay, or we might have a function of some other variable like time. So differentiation with respect to time of some other function, let's say h of t, is h prime t. So this is obviously a function of whatever the variable t is. Typically it's time. Okay, so h prime becomes the derivative of h. So it means that it is the instantaneous rate of change. Okay, Raghu, is this clear, this point?
Yes, sir.
Okay. Okay, so that's just a matter of notation. Okay, now next we will look at some new formulae in differentiation. So additional formulae for differentiation. So first of all, we look for trigonometric functions. So at this stage, you have to just memorize these formulae. Okay. Later, when you come to advanced calculus in class 12 maths, you will see the derivation of these formulae by the first principle method. That is that limit method of differentiation of fx is given by f of x plus delta x minus fx, that method. Okay. So differentiation of sin x becomes cos x. Differentiation of cos x is minus sin x, and differentiation of tan x is sec square x. Okay. In maximum part of physics, you just need these two. Even the third one is not very often used in physics, but you should know it because there can always be situations where we require it. And similarly, even more rare than this are the derivatives of the other functions. Cosec x, its derivative is minus cosec x into cot x. Okay. And differentiation of sec x is sec x into tan x, and differentiation of cot x is minus of cosec square x. So as I said that we will not be bothered with the derivation of these formulae for physics at this stage. Okay, though technically the derivation is not difficult. You just need to apply the fundamental definition of derivative and apply some properties of trigonometric functions or trigonometric operations. Okay, some of those properties you may or may not have done in trigonometry yet. Okay. For us, what is important is the formulae. So just to illustrate how this works in terms of the conceptual understanding, for example, suppose I have given the function y equal to sine x. Okay, and I want to do the following. First is I want to plot the graph of y versus x for x equal to 0 to 2 pi, for example. Okay, and then also we want to find dy by dx or its derivative. Want to find the derivative of the function. And next up, what we want to do is find the slope of the tangent to y equal to sine x graph at x equal to, let us say, pi by 6, x equal to pi by 3, x equal to pi by 2, x equal to, let us say, 3 pi by 2. And x equal to 2 pi, suppose. Okay. So let's concentrate on this question now. So to begin with, I'm sure in trigonometry, all of you are familiar with by now with the basic graph of y is equal to sine x from 0 to 2 pi. So the first thing, this graph is just a factual matter that the graph of y equal to sine x, it looks like this wave. We plotted just up to 2 pi. It looks like this way. Also, of course, you know that pi by 2 is equivalent to 90 degrees. Pi is equivalent to 180 degrees. 3 pi by 2 is equivalent to 270 degrees. 2 pi is equivalent to 360 degrees. Okay. So for example, pi by 6 is the same as 30 degrees. Pi by 3 is the same as 60 degrees. Okay. 90, this is 270. Okay. This is 360. Let's also add pi. Okay. So we know that the graph of sin x, roughly speaking, looks something like this. Okay. Sin pi by 4, for example, is 1 by root 2, which is approximately 0.7. Then that value again repeats at 3 pi by 4. Sine of 3 pi by 2 is -1. For example, sine of 5 pi by 4 is minus 0.7. So pi by 4 is 45 degrees. 3 pi by 4 is 135 degrees. 5 pi by 4 is 225 degrees. And 7 pi by 4 is 315 degrees. Okay. So just make a brief note of this graph. Okay, so like I've given you an idea of the y equal to sin x graph from 0 to 2 pi. You should also, from your maths portion of trigonometry, you should also eventually have a very good idea of the graphs of all the trigonometric functions: sine, cos, tan, cosec, sec, and cot, all 6 of them. Okay. Now let's come to the derivative part. So derivative of the function y equal to sin x. So what is the derivative? As we have discussed, it's the rate of change. It's the instantaneous rate of change. So to find the derivative, you have to apply the process of differentiation, which in this case, we will just directly refer to the formula that differentiation of sin x is cos x. So you'll say that the derivative of this particular function is this. The derivative of sin x. So what the meaning of derivative is that at any point, if I want to find the slope of tangent, equals to the value of the derivative at a particular point. So this is the meaning of the term slope of tangent, or this is how we calculate slope of tangent. So for example, at x equal to, what was it, pi by 6, the slope is equal to the value of the derivative at pi by 6. So it is cos pi by 6, which is root 3 by 2, which is approximately 0.85. Actually. Similarly, at x equal to pi by 3, the slope is the value of the derivative. That is cos x at x equal to pi by 3, which is cos pi by 3, which is 0.5. So like this, we'll calculate each of them. At x equal to pi by 2, the slope will become cos pi by 2, which is 0. At x equal to 3 pi by 4, the slope of the tangent will be cos 3 pi by 4, which is minus cos pi by 4.
Sir? Sir?
Yes.
Sir, could you please explain D part?
Okay. Just a minute. B part, this one? This?
D. X is
D.
equal to 3 pi.
Achha, you don't know trigonometry in second quadrant? You haven't studied this in trigonometry yet? When theta is between 90 degrees and 180 degrees, how do we calculate cos of theta? Comes from this formula that it is minus cos 180 minus theta. Okay. So for example, cos of 120 is minus cos 60, which is minus half. Cos of 150 is minus cos 30. Have you seen this formula in trigonometry yet or not?
Yes, sir.
Yes, sir.
You've seen this formula, no, beta?
Yes, sir.
So that's what we are applying. So in this part, 3 pi by 4 actually is how much? It is 135, no? Okay. So cos 3 pi by 4 is minus cos pi by 4. Okay. Or cos 135 degrees is minus cos 45 degrees if we write it in degrees. Okay. So understood now, no? How it's come?
Yes.
Okay. Now, the more important thing for us is that once we've calculated these rate of changes, we can make sense of it from the graph. Okay. So going back to the graph of the function, you can see that the shape of the graph is such that you should be able to justify why the slope is positive at certain points, negative at certain other points, and so on and so forth. So for example, you can see that at pi by 2, if we draw the tangent, it should have a zero slope. Okay. Similarly, we had seen the point pi by 6, which is 30 degrees, which would be somewhere here. We had seen the point pi by 3, which is 60 degrees, which should be somewhere here. We had seen the point 3 pi by 4, which should be somewhere here. Then we had seen the point 3 pi by 2, which is somewhere here. This point is 2 pi. So if you now just use the values which we have seen, you can see that if you draw a tangent at these various sort of points, you'll see that this is the tangent at this peak point. Which is going to be a flat line. This is the tangent at this particular point here, which corresponds to pi by 2. So you can see that the slope at pi by 2 is 0, because it's going to be a flat line like this. Okay. Similarly, if we draw the tangent at pi by 6, you can see that it will be a straight line like this. It will have a positive slope. This one we saw, it has a slope of 0.86. Okay, but compare that with the tangent that we've drawn at this point pi by 3. You can see it's having a lesser slope because the shape of the curve is changing like this. So this is how we can correlate the information from the graph with what we are getting from differentiation. Because at this point pi by 3, the slope is like this green colored line. Okay, the tangent is like that green colored line. So this is having a different slope. This is having a slope of 0.5. Similarly, if we draw the tangent at this point 3 pi by 4, you would see that we get a line which has a negative slope. So we saw that that slope is minus 0.7. Similarly, if we draw the tangent at pi, we saw that it has a slope of minus 1. Again, we draw the tangent at 3 pi by 2. We see it has a slope of 0. And we draw the tangent at 2 pi. You see it has a slope equal to 1. The same as the slope at 0. So this information, see how it correlates with the shape of the graph versus what we are seeing from the values of the slope of the tangent, and how we've calculated the values of the slope of the tangent by calculating the derivative of the function from the formula. That derivative of sine x in general is cos x. So the slope at pi by 6 is equal to cos pi by 6, which is this much. So the slope at pi by 2, for example, is cos pi by 2, which is this much. So all this information you can see in the graph below. Okay, so this is the relationship between the shape of the function's graph and the value of its derivative at various different points. Harshit, to answer your question, it is not the slope which is the form y equal to mx plus c. Y equal to mx plus c is the equation of a straight line. And this straight line has a slope equal to m. Okay. Of the tangent at, for example, x equal to pi by 6. So that will be the equation of a straight line which has a slope equal to whatever slope we had calculated at pi by 6, which was root 3 by 2. And it passes through the point, okay, let's say x1, y1, where x1 is that point pi by 6. So y1 is the point sine pi by 6, which is half. Okay, so on the graph of sine x, let's say this is the point whose x coordinate is pi by 6. So its y coordinate is half. So now we want to find the equation of this straight line, which is the tangent. This, okay. The equation of the tangent line will become of this type, okay, where the slope is this much and it is passing through these points. So we can find the equation of the tangent by using the coordinate geometry formula y minus y1 is equal to m times x minus x1. So in this case, y minus half is equal to this slope, which is root 3 by 2 times x minus pi by 6. So you can see that the equation of the straight line will be this whole thing is that y-intercept constant. Is it clear now?
Yes, sir.
So generally, when we are looking at the concept of derivative and slope of tangent, we are just interested in the quantity m, not so much in the whole equation of the straight line y equal to mx plus c. But in case we want to find the equation of the straight line, we can always do it by using this method. Okay. And I've also given you a question like that in the worksheet. One of the questions I asked you to find the equation of the tangent at a particular point, and I've explained it in the hints. This whole process. Okay. So now, having understood this question and having seen the formulae for differentiation of trigonometric functions, now let's continue ahead with some more formulae. So next set we will look at two special functions. One is the exponential function. So this is again a function that you will may not be familiar with from before, but it's a very important function in physics from this point onwards. This function is given by the formula y is equal to e raised power x, where e is an irrational number, which means that it's a non-terminating, non-recurring decimal. Okay, of approximate value 2.7. Just like pi is an irrational number of approximate value 3.14. Like that, e is called the exponential constant. And it has an approximate value of 2.7. So the graph of this particular function, it has a shape like this. So these are some of the features of this graph.
So why there is 1 by e?
Why it is, sorry?
So why you
What?
have written 1 by e?
1 by e is the same thing as e to the power minus 1. No? So I have shown it over here. Okay, that if you substitute x's value is minus 1, from the formula y's value is e to the power minus 1 or 1 by e, that's the same thing.
Sir, how e raised to minus 1 is equal to 0.31?
Because I've given you the value of e, no? So 1 upon 2.7 is, it's 7, 3, 7 actually, okay? So if you calculate this, approximately 1 by 2.7, because 2.7 is the approximate value of it. Okay, clear now?
Yes, sir.
Okay.
Sir, how is this formula useful?
I'm explaining. Okay, next when we see the derivative, it's more a question of how this function is useful. And this is a function. It is called the exponential function. Now, why it has a significance, the exponential function? Because when we look at the derivative of the function, then it's something very unique. Okay. Now let's come to derivative of the exponential function. So as it turns out, the derivative of the exponential function has a value of the function itself. So this is the unique property of the exponential function. No other function in maths has this property, that the derivative is equal to the value of the function itself. Okay, so for example, the slope of the tangent to the function y is equal to e raised power x at x equal to 0, the slope is equal to e raised power 0 or 1. Okay, at x equal to for example, at x equal to 2, the slope will be e raised power 2, which will be approximately something little less than 9. Okay. At x equal to, for example, minus 2, the slope will be equal to e raised power minus 2, which will be approximately 0.14, like this. Okay. And you can see this feature. You can understand it from the shape of the graph also. This is a graph of y is equal to e raised power x. And for example, if I draw a tangent at this point, looks like this. Okay. But if I draw a tangent at a larger value of x, accordingly slope also increases. And it increases in such a way that this is in fact the value of the slope. And for example, here, if I draw it at a negative point, it's a flatter line compared to this one. So the further I'm going away from the origin on the negative side, the lesser the value of the slope is becoming, because e raised power x's value. So this is the unique feature that this function has in maths, that it's only one particular function which has this feature, that the slope is equal to the value of the function at any given point. Slope of tangent to y equal to fx equals to the value of fx. This is the property that this function has. And that's why it's extremely important in physics. When we see applications of calculus in various branches of physics, right from kinematics onwards, okay, but going up to branches like electricity, magnetism, etc., we'll see the exponential function keeps showing itself in many places, because certain physical properties will behave in the same manner. Okay, and the final formula for derivative next we'll look at is the derivative for the what we call the natural log function. So the natural log function is given by this symbol, okay, but ln actually stands for log to the base e, where e is that exponential number that we discussed. So this is the symbol used for natural log. So for example, natural log of 1, okay, is equal to 0, because e raised power 0 is equal to 1. Natural log of e is equal to 1, because e raised power 1 is equal to 1. Natural log of, let's say, e raised power 20 is equal to 20, because
Sir, below the natural log function is equal to.
sorry,
So below the natural log function, y is equal to, what is that? It's a symbol or what?
which one? This
Symbol of natural log.
symbol of natural log is ln.
Okay.
Ln, okay, small l, small n. So this is the definition of the function, that it is log to the base e. Okay. Now the derivative of this function, and the reason why this function is important, is that this is the function which has a derivative of 1 by x. So apart from the 6 trigonometric functions that we discussed earlier, these are the 2 other important functions whose derivative you should know. The exponential function, its derivative is equal to e raised power x, and the natural log function, its derivative is 1 by x. Okay, so once you're familiar with all these formulae, like differentiation of x to the power n, which we had discussed in the last lecture, then the differentiation of the 6 trigonometric functions and the exponential and ln function. So you know all the required formulae for differentiation. Along with the formula, of course, you have to make use of the properties of differentiation. So we've already discussed a couple of properties like differentiation of a constant into a function, the differentiation of sum or difference of two functions. Now continuing ahead with more properties. So next one we have is the product rule. If a function is expressed as the product of two functions. So for example, if y is equal to, let's say, x into sine x, so it's the product of these two functions, okay, then the derivative of y with respect to x is given by this formula. Differentiation of first function multiplied by second function plus first function multiplied with the differentiation of the second function. So it is precisely for these type of formulae that the short form becomes very easy to use, okay, because here by f prime x we just mean differentiation of this function, and by g prime we mean differentiation of this second function. So when we apply it over here, for example, on this question, it will mean differentiation of the first function multiplied with the second function plus the first function multiplied with differentiation of the second function. Okay. And next step we can work this out. So this is 1 into sine x plus x into cos x. So it becomes sine x plus x cos x. So this is the property, and this is an example of how we use this property for this. Okay, so take down this along with the example and try out the following question. Okay, so just try this question, people. Okay, very good. So many people have got the answer correct. Okay. Siddharth, Shivansh, Adinath, Harshit, Anshul, Pratyush. Some of the people who got the answer correct. So let me work it out for everybody. So differentiation of x square into e raised power x. So we will treat this like a product of two functions where the first function is x square and the second function is e raised power x. So the derivative of the first function is 2x and the derivative of the second function is e raised power x. Okay. So if I write this properly, I should write it as differentiation of first function multiplied by second function plus first function multiplied by differentiation of second function. And then just use the formula. So differentiation of x square is 2x and differentiation of e raised power x is also e raised power x square. So then we can write it in whatever form we want, like this or whatever, but even this step is correct. So this is the derivative of the function. Both these steps are equally okay. So we can see that the value of dy by dx at the point x equal to 1 just becomes becomes 3e. So that becomes the answer to this part. Okay. So this approximately we can say it is 3 into 2.7, but we don't need to do that. We can just leave the answer in terms of e. That's fine. Okay. Now, likewise, we have another property called the quotient rule for differentiation, where we are differentiating the division of two functions, or what we call the quotient of two functions. Just a moment, people. I will reshare that file. Okay. Yeah, so quotient rule. So if we have a function which is the quotient or division of two individual functions. Okay. Now this one looks quite complicated. The differentiation of this function is given by this formula. It is the denominator into the differentiation of the numerator minus the numerator into differentiation of the denominator divided by the denominator function whole squared. So in short, you can also write it like this, that if the function is some numerator divided by denominator, then derivative of the function is like this. So this is called the quotient rule. So for example, if I have a function y is equal to x square upon 1 plus x, then differentiation of y with respect to x will become denominator into derivative of numerator minus numerator into derivative of denominator divided by the denominator whole squared. So next step, this will become the derivative.
Sir, done.
Right. So you understood this question, all of you?
Sir,
Yes. Tell me.
sir, can we use the product rule if we take like the numerator is n and denominator is d? So can we use product rule on n and 1 by d?
Yeah, you can do that also, but it might not be so easy to do sometimes now. You understanding? Like we have the function, suppose, like like we have the function, let's say sin x upon x. So you can always interpret this as sin x into x to the power -1 and use product rule also. Now you can see that both will give the same thing. If you use the quotient rule, you will have denominator into differential of numerator, okay, minus numerator into differential of denominator divided by square of denominator. So let's see what we'll get. So we'll get x cos x minus sin x divided by x square, which we can write as cos x by x minus sin x by x square. Okay. Now we can also use the product rule here. So you can see that it is differentiation of sin x into x to the power -1. So that is differentiation of first function into second function plus first function into differentiation of second function. And that will give us the same thing. This is cos x into 1 by x, and this will become sin x into -1 by x square. So that's the same thing as this. Okay. So in a case like this, it's quite feasible to use either of the two, but there will be instances where it will not be so feasible. So I'll discuss that also. So for example, if we have a function like this now, that y is equal to x upon square root of 1 plus x square. Now using this method, converting it into a product is not going to be as easy as just interpreting it in terms of a quotient. So that's why we should know both the properties. Okay, is this point clear?
Yes, sir. Yes, sir.
Okay.
Thank you.
Okay. Now we come to the final property, okay, which is called chain rule. So chain rule for differentiation, it is used when we have something called a composite function, that is a function of a function. Okay, so this is used to differentiate composite functions. So a composite function is a function of the type something where there are two operators applied on x. Okay, so this is an example of this would be y is equal to, let us say, square root of 1 plus x square. Okay, so to describe this function, we have used two operators. One is the quadratic operator 1 plus x square, and then the other is the square root function. So how we have got from x to y here is that on x, first we have operated the function fx, okay, and then we have operated, or let's say the function gx, whatever. We can use it in any order, the symbols, it doesn't matter. But so on x, we have first operated f. So we've got fx. Okay. So in this particular case, that is the 1 plus square term. So fx was 1 plus x square. Okay. And then we've operated g, but we've operated g on fx. So we've got g of fx. So that g in this particular case was the square root operator. So what we have got it is square root of fx, or that is the same thing as square root of 1 plus x square. So whenever we have this type of function, it is called a composite function. Okay. Another example of a composite function would be y is equal to sine square x. So in this, what we have done is on x, we have first operated the function sine. So you got sine x. And then on sine x, we've operated the function whole square. So we've got sine x whole square, which is sine square x. So the first function that we operated, let's say g, that is the sine function. And then operating this on, now we've operated f, which is the whole square function. So we've got f of sine x, which is f of gx, and that is equal to sine square x. So when there are two operations involved, or can be more than two also, but when there is a layer of operations, one operation on top of the other, we call it a composite function. So for composite functions, we use for differentiation, we use chain rule. So for differentiation of such functions, by what is called chain rule, we follow a series of steps. So the first step is called the substitution step. In this step, we introduce a dummy variable. Okay. So for the function f of gx, let's say, we introduce the dummy variable z, which is gx. So y becomes a simple function f of z. Okay, so this is my substitution step. Now, once you've done this substitution step, we introduce the second step, which is the chain rule step. So the chain rule is given by this, that rate of change of y with respect to x is rate of change of y with respect to z multiplied by rate of change of z with respect to x. This is the chain rule. And the third and final step to get the answer is resubstitution. So in resubstitution, we can see for this one, dy by dz is differentiation of fz with respect to z, which we can write as derivative of fz, okay, which in turn becomes derivative of f for z substituted as gx, because that is what we had substituted here. So this is resubstitution. Z is resubstituted as gx, and of course dz by dx is equal to differentiation of the function gx with respect to x, so it becomes g prime x. So on resubstitution, we have dy by dx becomes f prime of z, where z is gx, okay, multiplied with the derivative of z with respect to x, which is this. So this becomes our final answer. Okay. So this might appear a little bit confusing in the beginning, but we will see an example, and in a couple of minutes with that example, it will become very clear how to apply these steps. Okay. So just make a note of this first.
Could you please lower the screen? Scroll the screen.
So while solving the questions, do we directly use the last step?
You can, but it will take some experience in solving problems before you can do questions directly without making a mistake. So that's why I've given you the step-by-step method. So till you get enough practice, now what you should do is you should always apply the steps. For example, let's take this function that we had, square root of 1 plus x square. So we are treating it like f of gx, okay, where gx is the function 1 plus x square and f of gx is square root of gx, right, which is square root of 1 plus x square. So now to find dy by dx, what we'll do is first step, we'll apply the chain rule. We'll apply the substitution. So for substitution, we will substitute gx as z. So in this case, we will substitute z as 1 plus x square. Okay, so this is our assumption. So therefore, y becomes how much? It becomes square root of z. So this is my substitution step. That if I substitute this whole thing inside the square root as z, then y becomes a very simple function of z. It is z to the power half. Okay. Then the second step, the chain rule. So dy by dz, sorry, dy by dx is equal to dy by dz multiplied by dz by dx. So this will become differentiation of this function root z multiplied with differentiation of this function. Okay. So differentiation of root z, as you know, is 1 by 2 root z, right? And differentiation of 1 plus x square is 2x. So this becomes x upon root z. Now the final step, the resubstitution step. So in that we resubstitute z as what? 1 plus x square. So that becomes my final answer. So in the resubstitution step, all I'm doing is here, I'm just resubstituting z as 1 plus x square. So I've got this. Okay, so with a bit of experience, you can do these steps more efficiently. Okay, but at least in the beginning, for working out the exercise in your module and all that, I would suggest that, plus I'll be giving you a worksheet also today. I would suggest that you clearly write out the 3 steps so that you don't make any mistake. So from this, you can also directly do like this, that dy by dx is f prime of g into g prime x. Okay, so f is the function square root. So f prime should be the function 1 upon 2 times square root of whatever is here. and g is the function 1 plus x square. So g prime is 2x. So accordingly, this should become 1 upon 2 times square root 1 plus x square into 2x. Okay, so there will be a time when you will be able to do this directly. Okay, but as I have said before also, okay, the idea is not extreme speed in the beginning. The idea is that extreme accuracy. Once your accuracy is very, very good, then with practice, the speed will automatically come. But if you try to be very fast in the beginning and in the process, you get into the habit of making mistakes, then it will take a long time to overcome making the mistakes and the tendency to make careless mistakes. Okay, so it's better that you do enough practice in the step-by-step manner first, and then you can come back to shortcuts and fast substitutions. Okay. So anyhow, that's it for today's session, people. So there will be another worksheet I'll be giving you, and don't forget on Sunday we have an additional doubt session for physics. So we can discuss some of the questions or any concept that you want to rediscuss. You can do that both for vectors as well as calculus. Okay. So that's it for today's session, people. Thanks for attending and wish you all the best.
Thank you, sir.
Thank you, sir.
Thank you.